What is a fraction? A lot of my students get turned around when the question is really just asking you to represent the material as a fraction. So let's just make a note of what is a fraction. Get your note card out and write really big, what is a fraction on the top? This is going to be your title. So simple. So what is a fraction? It is a part over a whole. And then I want you to write underneath that really big, part over whole. So the numerator, top number, is the portion that we're talking about. The bottom number, the denominator, is the whole. And don't forget that we have to reduce them. Okay? They have to be reduced. And you can use your calculator. If you're going to be on the high set, then you can, let's say you got 5 over 10. Okay, is your fraction. So you 5, n over d, 10, hit enter. Remember, that's how you reduce, and it reduces it for you, 1/2. If it's already reduced, like 1 over 2, well, that's already reduced. But if you're not sure, you just put it back in your calculator, hit enter, and it just gives you the same thing you started with. I don't know if you can see that. So when in doubt, just get your calculator out and try it on the calculator. So let's just do a couple of practice problems distinguishing what is a fraction. And this comes in after our section of ratios. Remember, we talked about ratios. Ratios were a comparison of two values, and really they're just a special kind of fraction. And they have different rules. Remember, in fraction world, you could never leave anything improper. So as a ratio, they can be improper. Think about comparing pens to erasers, okay? Pens to erasers. So if I have 5 pens and 3 erasers, then the ratio would be 5 to 3. We would never change, we would never make that a mixed number, 1 2/3. That doesn't make sense if that's a ratio. So ratios can be improper, but they must be reduced. So if you're working on these problems from your number sense book, which I like, and you're on these problems about ratios, there is a section in there about fractions. So we're trying to bring our attention to what's the difference between a ratio and a fraction. And they're both very simple concepts, but they're represented slightly differently. So we're going to do just a couple of these problems together, and just to bring your awareness to that. So remember that a fraction is a part of over a whole, whereas a ratio is a comparison of two values, but they still have to both be reduced. Now, number 7, it says, what fraction of the shapes are squares? So I'm looking at this picture here, and it's asking me for the fraction. So remember, fraction is part over whole. So if you're looking at this, what is the part that I want on the top? Do I want squares or shapes? Well, squares would be my part, 2, 4, 6, 8. I have 8 squares. And it has to be over the whole amount. And I want you to notice that the way it's written in the question, shapes comes first, but yet I put squares first on my problem. So that sometimes can get us thrown off. But we want shapes on the bottom. So we wanted squares. It helps sometimes to label these things. And we want shapes on the bottom. So if you count up your shapes, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, you've got 24. So the fraction of squares to shapes is 8 to 24. But remember, you have to reduce it. So get your handy dandy calculator and plug that sucker in. So 8 over 24, use your ND button, hit enter, and you get 1/3. Now let's talk about how to say this. 1/3, that's not 1/3. That's 1/3. Think of the bottom number like you're in line, like your place in line. So I always think of the driver's license bureau. If you're at the driver's license bureau and your little ticket number says 3, you're third in line. So this is 1/3. You say the top number and then you say the bottom number as if you were in line. Now let's go on back to our problem. So looking at number 8, write the ratio of squares to circles. Now wait a minute, so they're asking for ratio, they're not asking for fractions. So a ratio is not a part over whole. A ratio has to be in the order that they asked. Remember, we set it up like a fraction. Remember your steps. Write your fraction line, label, ratio of squares to circles. So I wanted squares on top and I wanted circles on bottom. Then I go over here to my picture. We know we have 8 squares, we've already counted them. We only count the circles. Notice the difference here. On the fraction, I counted the squares in with the shapes. So I counted the 8 squares plus all that other stuff. On the ratio problem, I count the squares, then I count the circles. They're separate. They're improper, okay? That's okay. Remember, in ratio world, we've got different set of rules. We put it on the calculator, and we see that it is 4 to 3. Now notice how we say this. We do not say the place in line here. We say this 4 to 3. So it reads differently. So there is a difference between a fraction and a ratio, and it's a very simple concept, but oftentimes we miss these real simple questions because we forgot what a fraction is and how to write a fraction. All right, let's do another one. What fraction of the shapes are triangles? So we're looking at our picture over here. What fraction of the shapes are triangles? So if we're looking for a fraction, we need to write our fraction line. And remember, it's part to whole. So triangles would only be a part of this whole picture. So how many triangles? 2, 4, 6, 8, 10. And how many shapes do you have all together? We wanted triangles to shapes. And we know we have 24 from our previous problem. And so we're not done because we have to do what? We have to reduce it. So 10, N over D, 24. Hit your enter button. You got 5 over 5. Now, how do we say this? 512 is what I get a lot of times. No, it's not 512. And picture yourself in line at the driver's license bureau. Your number says 12. And you text your friend and you say, hey, I'm what place in line? You are 12th with the TH. Okay, 12th. So that is 5/12. That's how you say that. One more. We're going to do one more. So looking at number 10, write the ratio, different set of rules of triangles to squares. So ratio, remember, write your fraction line, label triangles, label squares. That was the order they asked it for. Triangles, we know from the previous problem, was 10, right? And then we need squares. We've already counted those, so we know that those are 8. Oops, this is improper, but remember, as a ratio, improper is quite all right, but it still has to be reduced. So you have 10, and then it's over 8, and our answer is 5 over 4, but how do we say it? Do we say 5/4? No, because this is a ratio. We say 5 to 4. If I'm talking about comparing triangles to squares, we say 5 to 4. Now, one more quick problem I want to show you, because this is, we see this a lot of times in more of a standardized test situation. The picture ones we don't see too often. But I'm going to show you this number 13. The ratio of boys to girls in a class is 5 to 7. So they tell me my ratio. What fraction of the class are girls? All right, so they're giving you the ratio, right? And the ratio is 5 to 7. And notice they didn't put it in a fraction form. And they're asking what fraction of the class are girls. All right, so now I need a fraction. Of the class means that's my total amount, class. And the part of the class would be my girls. Remember, it's part over whole. So we need the girls on top. Well, now you've got your ratio, and it said your ratio was boys to girls. So you had to make a note of that. So this ratio, boys was listed first, and girls was listed second. So how many girls are in your class? There's 7, right? But now how many people are in your class? Not 5, because 5 just represents the boys. So how many people are in your class? Well, obviously your class is made up of 5 and boys and girls. So what are we going to do with those two numbers to get my total class people, or class count? We would have to add that together. So 5 plus 7, do it in your calculator if you want to, is 12. And there is my fraction of 7 of girls to the whole class. And it's 7/12. But wait, don't forget, you have to reduce it. So if you're not sure if that is reduced, we put it in the calculator, we hit enter, and we see we get 7/12 again on the calculator. So that was already reduced, and so the answer is 7/12 with a TH on it, and that's how you do those.